Good afternoon, class. Today we're going to continue our discussion on proportional relationships, and we're going to move forward to learn how to graph proportional relationships in mathematics. So, to begin, let's do a quick review of what we've learned so far. We've learned about the numbers and the relationship between the x and y coordinates, right? So in this example, we've got our x coordinates and the corresponding y coordinates. So if x is 1, y is 3. If x is 2, y is 6. The question is this proportional, and how can you tell numerically? Well, we put y over x, and we take the 3, make that the numerator, and then the 1 from the x, make that the denominator. 3 over 1 equals 3, right? Well, the next row of numbers, 2 over 6, also equals, 6 over 2 also equals 3. 27 over 9 also equals 3. So no matter which set of coordinates you choose, y over x is always going to be in a multiple of 3, therefore it is proportional. Now let's look at an example where it is not proportional. Now we've got a and b. Everything's the same. The 1 over 3, 2 over 6, but here it's green, we get 10 to 35. Now if 35 is the numerator and 10 is the denominator, then it's not going to be in a multiple of 3. So therefore, this is not proportional. It is not going to increase by the same rate in the same multiple. Now, let's just go ahead and point this out as well. It doesn't matter which one you choose as your numerator. In this first example at the top where it is proportional, we chose the y value as the numerator, but if we were to reverse it and have the x as the numerator, then 1/3 equals 2/6 equals 9 over 27. They're all multiples of 1/3. Applications in the real world. What does this mean to us? What is the proportional relationship that we're familiar with? 2 gallons of water per minute. The average shower releases 2 gallons of water per minute. So every minute that passes, you will use up 2 gallons of water in your shower. Apple pies, $5 each. No matter how many you buy, it will always be in multiples of $5. If you buy 1, it'll be $5. If you buy 10, it'll be 50. But it will always be able to divide it by 5. And that's a proportional relationship. Okay, what to expect in this lesson? We're going to have many lessons, and we give you, plenty of examples. You're going to have a chance to practice this on your own, and you're going to see lots and lots of graphs. After all, that's what we're learning today, is graphing proportional relationships. So our first example, miles walked per hour. Now, if you look at this example, miles walked in the y column is represented in the vertical axis, which that is the y-axis, and then the x-axis is the hours. And we're going to determine whether or not this is proportional. So, for every 2 miles walked, or for every 1 hour, 2 miles have been walked. I know you know how to graph it. Let's just walk through this real quick. Start from the origin, 0, 0. And on the x-axis, you want to go to 1, and then you want to go up 2, and you're going to put your point right there, and you're going to continue on. What would make this proportional? There's 2 requirements that we need to see. 1, it needs to pass through the origin. It needs to pass through where x and y are both 0. 2, it needs to be a straight line, because it will always be the same multiple as it increases. In this example, after plotting all of them, you'll see it is a straight line, and it does pass through the origin, so therefore, this is a proportional relationship on a graph. Next example, fundraiser for selling t-shirts. So they are selling t-shirts for $1, you can buy 2 t-shirts, or 50 cents a t-shirt. Not very profitable, huh? However, it's always going to increase by 50 cents for each sale. Every t-shirt will always be 50 cents, a straight line, and it's going to cross with the origin. This is proportional. Excuse me. Here's an example where this is a golfer. And as they play, for each round of golf that they play, for every 3 rounds, they get 2 rounds on par. For every 6 rounds, they get 3, so on, so on. So if we graph this, is it going to be a straight line? Is it increasing at the same rate? It's a straight line, but it does not pass through the origin. Therefore, this is not a proportional relationship. Here's another one where time it takes to study for an exam. Now in this case, this student studied 0 hours and got 0 answers correct, which is to be expected. Next, they studied for 1 hour and they got 1 answer correct. Now that's a hard test. Then moving on, 2 to 4, 3 to 9. So as you see, the more they study, the more answers they get correct, the better they do. Now if we graph this, now it does pass through the origin, but you'll see it's not a straight line, it curves. So therefore this is not proportional. Okay, now this is one that I would like you class to perform. I've given you worksheets, so go ahead and start at the top of the worksheet. This is an example where Kaz fires arrows at a bullseye. And for 0 arrows, he obviously does not hit the bullseye. For 1, he hits it 1 time. Go ahead and plot these and draw the line, and let's discuss whether or not this is proportional. Okay, you're completed? Great. Let's take a look and see. Is this proportional? That's correct. We've got a straight line, and it passes through the origin where the x and y are both 0, so this is proportional. Let's try another example. In this case, you're just given x coordinates and y coordinates. Please go ahead on the next worksheet and graph this, and let me know if this is proportional or not. Okay, now that you're completed, you should have something that looks like this, correct? And this is not proportional. It is a straight line, but it does not cross to the origin. And I'm going to give you one last example. Go ahead and use the next worksheet and graph these, and let me know if it's proportional or not. Okay, we're complete. Great. Is this proportional? That's correct. It is not. Not only is it not a straight line, it does not cross to the origin. It meets neither of the requirements. So let's move on to the multiple choice section. You all have your clickers, and it allows you to answer these questions remotely. So here we've got, is an interpersonal relationship. A, the x and y coordinates will be equal to one another. B, the x and y coordinates will increase by the same multiple. And C, the x and y coordinates will increase by the same number. Please select whether it's A, B, or C. Let's take a look at the results. So it looks like we've got 1 student says it's B, and 2 students say it's C. So 1 student says x and y coordinates will increase by the same multiple. That's actually correct. The next student says the two others say x and y coordinates will increase by the same number. It can increase by the same number, but it does not have to. You can look at 1 to 5, and then, the next one go on to 3 to 15. You don't have to look at 2 to 10. So let's review that. The coordinates and proportional relationships, the requirements. The rate of change will increase by a constant multiple, not necessarily the same number, but multiple. For instance, for every mile that you drive, you will have traveled 50 miles per hour. You can check in for the first hour at 50, and then the 3 hours at 150. Next multiple choice. What requirements will be met when graphing proportional relationships? The coordinates must plot a straight line. The line must pass through the origin. Or both A and B, both must be met. Please use your devices to select your answer. Got the results in. So we have 2 students that have answered C and 1 student that has answered A. Okay, so somebody here says the coordinates must plot a straight line A. That's actually correct. However, the true answer is both A and B must be met. The line must pass through the origin and must plot a straight line. So it is actually C. It is A and B. Proportional relationships on a graph, the requirements. Let's review it one more time. There must be a straight line, it must go through the origin, and it must meet both requirements. Does anybody have any questions? Okay, so when it comes to mathematics, we're all smarter than the monkey that's got his hand up on the screen. I agree. Okay, so following today's lesson class, just so you know, we're going to have homework. I'll give you handouts as you leave. I need you to complete the graphing of proportional relationships at home. When we come in the morning, we'll do warm-ups first thing. You'll get a chance to practice proportional relationships right as soon as you come in the door. And we will have a quiz tomorrow, so please be prepared. And I'd like to thank all of you for your participation, including Shanae on the camera. Good afternoon, class.